Okay, so it's 9 a.m. where I live right now, and I'm kind of sleepy, so let's just get this over with. Okay, so basically, what this video is basically a demo video for an AI model that me and my team have already made called Heart2Go. It's basically an AI project where we made a heart abnormality detector using ECG Signal, and we utilized the 1D convolution neural network model, right? So we already made the 1D CNN model, and this is basically a video to show that the model actually does work, right? Okay, so here in this Google Colab notebook, I already made a little section here where we can essentially choose one ECG signal from our data set. Just before I go into a tangent, basically the data set we're using is the PTBXL publicly available dataset with over 20,000 samples. We're going to choose one random, well, not random, we're going to choose one sample, right, arbitrarily. And then we're going to run our model on that ECG sample. And we're going to see essentially a couple of things. So first things first, we're going to see our sample index, which is basically, the sample that we've chosen, right? We're going to change this number later and perform the actual demo. But anyway, the ground truth here is basically the label of the data. So basically, the data is already labeled by doctors or whoever made the data set, and we relabeled this as either normal or abnormal, right? Now, essentially, the ground truth is what the data is labeled as, so what it truly is, and the predicted class, which is the one under it, is the one in which is basically the prediction that our model makes. So yeah, we obviously we want the ground truth and the predicted class to be the same, because that means our model actually works at doing its job. And yeah, let's just hope we get it. Okay, so what I'm gonna do here is just pick a random sample arbitrarily. So let's just do 10. And then just for fun, we're gonna try plotting this sample here. So this should change. Okay, this did change. Nice. And then what we're going to do is we're going to run our model to try and predict it. And yeah, we'll see the result. Let's see here. Okay, so sample number 10 is normal. It truly is normal. And it's actually normal. And our model successfully predicted it as normal. So this is a true positive. This is good. This is good. This is what we want. All right, this is what we want. Right? So that works. Let's just do another one just for fun. All right, let's just do like 6, 7 for instance. All right, so we're gonna pick sample number 6, 7. We're gonna plot sample number 6, 7, which is different, right? This is different, and then we're gonna run our model through it, and then we're going to see what it does. Okay, so sample number 6, 7 is also abnormal. Its predicted class is abnormal. Confidence score is 1, which means yeah, we got it. It's nice. Let's just do another one just for fun. Let's do like 1, for instance. All right, let's do 1. This is the final one we'll do. Let's plot ECG number 1. This is ECG number 1 right here. Let's run our prediction. Let's get the result, and it's normal. Okay, so it's actually normal. And our model predicted as normal, which means I'm right. Yeah. So that's great. Out of the 3 that we did, our model successfully guessed whether it is normal or abnormal, um, quite well, I must say. And yeah, thank you for watching the video. Thank you for watching the demo. Let's hope we can, utilize this AI for something. I guess I don't know. Anyway, that's it. Bye bye.